B. Command C. That's so close, but it's not exactly. But that's what the spreadsheet is telling me. Okay, Marco, I think I'm ready to go.
Cool. Are you finished too? So let's do it. So we gotta be in question number 3. So I get a 2.
I got 2.
Awesome. Good. 4, I get 1.747.
I got 0.081.
Okay. Because you take only the right side, right?
Okay, so the probability of attaining the test statistic is greater than Jordan's, a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. So it's using this is the right-hand side of the bell curve.
Oh, I see.
Okay, so this is what the probability would be if it would be a hypothesis 2 is greater than 0. This would be the likelihood. But what it's asking is, what's the probability for it being not equal to 0?
Oh, so they want us to do both. I see.
Yeah, so essentially all you have to do is 2.
Yeah, okay. Let's see the force.
So I think you probably put the z or the t-score in there.
So this the 0.03 is the value of the area, right? Or,
yeah, that's how much area is underneath the bell curve.
And it's
So
it's on the sides or between it.
Here, check this out. All right, so okay, so that's the okay, so here, you're not sharing screens with me. Just a second.
Right, fine.
All right, share screens. Okay, can you see that?
Let me check. Yeah, that's what I did.
All right, so this is the probability, right?
Exactly.
The probability of it being greater than his test hypothesis, which you know is right here, is this, okay? But the probability of it being unequal to is both sides, 2 tailed tests. So it's 0.0806. If we round that up to 3 decimal points, it's 0.081.
Oh, I see what you mean. Oh, okay, I got it. I understand differently. Okay, question number 5. I have 0.407.
Okay, I got that too.
Good.
Hopefully it's right.
Yeah, 6 at 0.689.
0.689. Yeah, I got that.
Awesome. So it's failed to reject, right?
Yes.
Cool. 8, we have insufficient evidence that the mean of the differences is greater than 0. Is that B?
I got B as in Bravo.
Yeah, awesome. Got the same. Question 9, N is greater.
Okay.
A. 10, I got 0.001.
I got that too.
Cool. 11 got number A. Well, the A reject the null hypothesis.
Good. Got that.
12 decrease.
Got that.
13 reject. Right.
Yes, that's
Lower.
what I got too.
14 it's B.
All right, here, just a second. I marked C. Based on your response from the previous question, what conclusion do you make? You said B as in Bravo?
Yeah. Do you have that, or
We have insufficient evidence
because
that
we're rejecting the
there
hypothesis?
is no mean difference between the two groups. We have sufficient evidence that there is a mean difference between the two groups. All right, what was our null hypothesis?
It's that it's equal to 0, right? And now we're
Well, it's because we are rejecting the null and accepting the alternative, it's not equal to 0, so it's not equal to 0. And so the reason I marked C as in Charlie, we have sufficient evidence that there is a mean difference between the two groups.
we're taking the second hypothesis. Okay, that makes sense.
Yeah,
Cool.
because it's the equal sign with the bar, so it's a difference.
No, that's fine. So 15, I have the last one, D.
I put not enough information depends on the problem.
Because it's not always the same.
Yeah, I don't think it's always the same. Also, think about the problem we just did right here. It doesn't matter if it's greater than or less than. It's always going to be 0.0403. Oh, here we got. I can't unclick this for some reason. So here, let's see here. Oh yeah, this isn't letting me unclick it, but you get the idea. It's
No, yeah, fine. Okay.
Yeah.
16, I got 3.7.
Wait. Time out.
Because I did it in the problem, and then if you do the greater than 0, it's so much lower. But I don't know if that applies to everything else.
Yeah, I don't think that applies to everything, but I think I have to go back to a question up here
No,
and reread it.
You're fine.
Okay, what is the test hypothesis? Okay, no, I got it. Okay, we're good.
Good. Okay. So 16, I got 3.737.
Okay, so I got 11.955.
Let's see.
But frankly, I've been kind of struggling with what the point estimate is. Do you have a good definition of what that is?
So is the point estimate, is that T or what is that?
Well, T is the test statistic.
Point estimate. So
I thought that the test statistic was the mean.
Okay, so what's exactly the point estimate then? I guess I got confused with the other one. Let's see.
Okay, so
I guess, is that the standard deviation?
For this situation, the value is, okay, so the test statistic is the t-score, definitely. But I'm looking for the point estimate. I just don't know what that is.
So I just Google it, and it seems it is. It seems that is the standard deviation. Let me see. So the point estimate should be the sample variance, according to what I Google here. So let's see.
See, and it's not even in chapter 12. There's no point
So the
estimate
sample
in chapter
variance
12.
the standard
What'd you say?
is so the sample variance should be is the variance
All right, here's a second. To construct the confidence interval when standard deviation is not known, we replace the population standard deviation with its point estimate. Okay, so it is the standard deviation. So it's going to be the t-square. It's going to be 15.003.
okay.
Did you get that too?
Yeah, let's see. Yeah. Let's see my
Okay, well, that makes sense.
15003. So I just looking at online. It says it's a standard deviation to the square.
Wait, it's the, okay, so let me read you what it says in the textbook.
Yeah.
To construct the confidence interval when standard deviation is not known, we replace, okay, so standard deviation of the population is not known because it's sigma. We replace the population standard deviation, sigma, with its point estimate, standard deviation of the sample. The appropriate distribution is a t rather than a z, so replace z with t.
So it would be only, if it's only the standard deviation, yeah, we're at 15.003. That would
Yeah, that's, if not, we can square it if we
Yeah.
get it wrong.
be awesome. 17, I have 3.199.
17, you have 3.119.
Yeah.
Okay, I have 6.269.
Okay.
So the way I got that
Uh,
is I took the t-score with 95% confidence interval, so that's 1.96, the standard deviation, and then I multiplied that by the standard deviation divided by the square root of the population.
yeah. Well, the way I got it, I just took the all the numbers of group 1 minus group 2, and I use all those numbers and I plug it into the quantity Excel spreadsheet.
Okay.
Once the one that gives you the mean, the standard deviation, and all that.
Okay, standard error from the mean, you got 3.199. You see, but it's not asking for standard error of the mean, it's asking for margin of error.
Oh, okay. Let me see. So I guess this is a different number then.
Yeah, I asked my tutor what that's for, and he didn't know what standard error of the mean is.
Oh, that's a good one. Okay.
So
Yeah.
I don't know if it needs to be changed to margin of error. Here, let me show you my screen again.
You're fine. Let me look at
here, let's share screen. And you know, I'm not saying I'm right.
No, you're fine.
All I'm saying is I don't think that's right either. So you can see my Excel spreadsheets, right?
Yeah.
Can you see this one I just pulled up?
Yeah, I see it. So it's the same one I have. So
So
that's
can you see this one here though that I'm moving around as blue boxes on it?
Yeah.
Okay, so if you look right here, margin of error.
The 6.
So this is for the z-score, but it's the same thing. The only thing you have to do is the t-score. So just imagine this z is a t, right?
Yeah.
So we take the confidence level, which is going to be 1.09, and then we have the standard deviation divided by the square root of the population. So
I see. Okay, got it. So, and that's how you get the 6.269.
Yeah, that's how I got the 6.269.
That makes sense. Okay, cool. Yeah, thanks for
So
clarifying
if
that.
it's not right, I'm really sorry.
No, you're fine. That's right. It makes sense. So
Okay,
18, I got 5.303.
I got that too.
Okay, 19 would be 18.607.
Yeah, I got that too.
And that's it. So
Okay, cool. Let's
we didn't-
submit it so I can go take a nap.
yeah. You work pretty late, right?
Yeah, I try to take a nap before I go into work.
Cool. So we got only 16 and 17 wrong. The easy ones. That's weird.
Okay. Well, let's see what we got. Okay, so 16 and 17. Well, these are the ones that we have no idea how to solve. Remember, we have no idea what the point estimate is,
Yeah.
and I really don't know with the margin of error.
Mhm.
So,
Let's see. Let's redo those. So, I mean, the only thing I would say for 16 is the square of that based on what I've Googled. That's everything. I don't know what else. And
all right.
17. Let's see. 17 was the margin error. Let's see. Let's me put it here and try and find out.
Okay. Point estimates. How about point estimate calculator?
Oh, nice. That works.
All right. Number of successes, number of trials. I don't know if that is good. All right. Margin of error, math celebrity. Okay, so
Putting everything here. Let's see.
do we get the upper bound and lower bound correct?
Let me see. I think we did. Yeah, we got it right.
All right, what was the lower bound?
The lower, it's 5.303.
Okay, what's the upper bound?
It's 18.607.
7. All right, and what was the population size? 22.
Which one?
Population size.
Let's see. And let me look at it. 22.
Okay, so the point estimate looks like it's the mean.
Oh, I see.
Okay. The margin of error is 6.652. So this is what we need to do. Okay, so the margin of error isn't as difficult as I thought it was, according to this. So we'll go back and we'll try and figure it out. So, but basically you need to take the upper bound and subtract the
So if you plug these numbers that you found in the quantity analysis and find the margin error, I get that The error margin error is 11.985.
Excuse me?
So if I use all the numbers that we found in the quantity analysis spreadsheet, and I plug those numbers and the margin error formula, I get like 11.985.
All right, here, I'm going to share my screen with you, okay?
Yeah.
Do you have this pulled up?
Yeah, because you have T, you have 1.96, but I'm using 3.737 as T.
Okay, so here, let me do this on my calculator real fast.
Cool.
Just kind of show you what I'm thinking. And then let's see here. Is my calculator even on here?
I guess the question has, why do you use T as 1.96?
1.96.
Yeah, when here it says that T is 3.737.
Okay. So we don't need T to figure out what the point estimate is.
Oh no, I'm talking about the
Because
margin.
it's the mean.
The margin of error.
Okay, the margin of error is the highest, the high confidence error less the point estimate. Which is 6.652.
Let me bring a pen.
Okay, I think we can get that right. Knuckleball. All right. Okay, I'm going to open up the quiz again and start retaking it.
Okay, I'm just gonna copy.
Because I'm going to try and leave as soon as possible. Start quiz. Okay. Does it make any sense? Okay. True. True. True, true. Point 8, 1.0, point. Statistic. 0.689. 0.689. Key value. Oh. Statistic. All right, so these are the two that we missed. Point estimate, 1.95. Six, 2. Down 5.3 and 18. All right, so are you ready to go?
Give me a second.
All right.
Okay, what do you get for 17? I still get like a 11 something.
I got 11.955.
53.
Is that what you got?
Let's see. I get 11.953.
Okay.
We're close, I guess.
Okay. What did you get for margin of error?
Margin of error, that's what I get, 11.953.
Wait, for margin of error?
Yeah.
I got 6.652 for margin of error. The point estimate is 11.955. Or that's what I got the second time anyway.
So are you to get the margin of error, are you doing the calculation using all the data you're finding here and the quantitative spreadsheet?
What I'm doing is I'm taking the upper bound of the confidence level interval, and I'm subtracting the point estimate from it.
I see. What happens is then if you take these values and you actually do it for the formula of margin error, you're going to get a different number.
Yeah, if you do it with the formula, you get 6.269. What does your formula look like?
It's what are you using for the value of t?
Well, t is 1.96 because we're using a 95% confidence level.
If you put at 9.95 confidence, according to the spreadsheet, the t it's going to be 3.737.
Okay, so
let me check. Is that difference or greater than?
Okay, here, no. You're missing an important thing. Okay, here, let me share this screen with you again. All right, so if you remember from chapter 10, you had different confidence levels. So for example, if you wanted a 90% confidence level, you would put in 1.645. And that's what this little asterisk right here means, is that you don't put in the t-score, you put in the confidence level. So this is 0.9, this is 0.95, 1.96, and this is 99%.
Oh, I see where you got it. Where you put it. Okay, you put 95 and the thing. Okay, cool.
Yeah, so you need to multiply it by 1.96, not the t-score that you're seeing from the calculations here.
I got it. Okay, cool. So let's see. Thanks for playing that. Awesome. So how much you get? 17, it's what, 6 point what?
6.652. 6.652. I don't know if I said that or not.
Yeah, 6.652. And what you get for 16? So at the end, what exactly is the point estimate?
The point estimate, as far as I can tell, is the mean.
Oh, okay, so it would be pretty much the mean. that we-
Yeah, what you can do though is you can take the lower
Yeah.
confidence level plus
Cool.
the upper bound and then divide it by 2.
So 11.955.
Yeah,
Okay, cool. Okay, put the answers and see what happens.
yeah, here.
Well, we won't get any lower than 90%. So let's see here.
All right, 20 out of 20.
Perfect.